between what it means to be human and what it means to be non-human can become quite blurred.
I believe
they've got humanoids.
A man-bear pig.
What we've created is a robot with a biological brain.
The globalists want to play God.
Do you ever wonder what kind of science experiments go on in the world that we may never know about? What kind of miracles and horrors have been committed in the name of science? Is science fiction an impossibility, or already a scientific fact? How far can we stretch the limits of our own humanity? What makes us human? In 2016, Magdalena Zernicka Gutz grew human embryos in a lab dish for longer than anyone had before. Her team at the University of Cambridge watched the embryos develop day after day, breaking all prior records. However, on day 13, she halted the experiment, having hit up against an internationally recognized ethical limit called the 14-day rule. The 14-day limit arose after the birth of the first test tube babies in the 1970s. Scientists had agreed never to allow human embryos to develop beyond 2 weeks in their labs. That is the point at which a spherical embryo starts to form a body plan, deciding where its head will end up, and when cells begin taking on specialized identities of different body parts. However, if scientists were allowed to bypass these ethical limitations, they could make remarkable progress in growing embryonic cells and watch them develop. It would turn out, in May 2021, the International Society for Stem Cell Research removed the 14-day limit. This would release the floodgates to new experiments. For instance, some labs are creating human-animal chimeras through experiments including mixing human cells into various animal embryos.
This is it. Human stem cells being injected into a pig's embryo. For the first time, scientists are seeing how our cells grow and interact inside an animal. Scientists would delete a specific piece of an animal's DNA, so its embryo wouldn't be able to grow a heart, for example. Then they'd inject that embryo with human stem cells, which move into the void and grow a human heart. The embryo would then be put back inside the animal to develop.
The possibility of growing human cells and tissues inside animals is an exciting first step.
As technology progresses, there would be debate as to whether synthetic embryos have any rights, or if they can ethically be used limitlessly for the progress of science and medicine. Things start to take a much weirder and darker turn when you start to blend the experimentation of organic life with current breakthroughs in robotics and artificial technology. Environmentalists worry, how do we create enough power to be able to sustain AI without harming the planet? What feels like something out of the Matrix, scientists at the University of Michigan are currently turning to harvesting human stem cells to build batteries for AI supercomputers. The most sought-after source of the stem cells for these organoids are embryos. These would be called bioprocessors, which researchers say would use about 1 million times less power than that of a digital processor. However, pure energy source isn't the only use case for these new cells. It has been long desired to train AI to think and learn like a human can. The New Yorker estimates that ChatGPT uses as much energy as 17,000 households every day. But instead of building digital, artificial brains, why not grow biological brain cells to create neural networks, and then merge them with technology instead? Tech company Final Spark is already doing just that. Essentially, they are building a living computer by growing human brain cells, which they claim the organoid has 10,000 neurons packed into a blob of tissue 0.5 millimeter thick. When they start connecting these organoids, they can then send and receive electrical signals, allowing them to learn and perform tasks. Teaching the organoids can be done through electrical stimulation or with chemicals like dopamine. So far, Final Spark claim they've used more than 1,000 organoids to collect more than 18 terabytes of data. Final Spark believes humans can be the solution to the environmental problems associated with intense computing. While creating organic robot hybrids might seem like something new, it is something that has been achieved before, only with rats, Researchers have successfully paired neurons of a rat's brain to small robots with sensors which transmit data back to the rat by Bluetooth. Many have expressed ethical concerns, cloning and growing a rat's brain and giving it a box and wheels for a body. Some reference the story, "I have no mouth and I must scream," will be literally stuffing animals in robots like Dr. Robotnik. Maybe one day a rat brain will be able to control my Roomba, so it actually works. I am no mouse and I must scream. What do you think about the breakthroughs of stem cell technology? Do you imagine a brighter future ahead, or a dystopian hellscape?
You can't just go along with what people are saying, Susan, okay? There's no scientific proof, no real evidence of a man-bear pig.
Well, there's a lot of smart people saying man-bear pig is real.
Yeah, and a lot of smarter people saying it isn't, okay? What you need to understand, Susan, is that everyone has an agenda, okay? Everyone wants to use the fear of a man-bear pig to get what they want.
A system that understands us better than we understand ourselves can predict our feelings and decisions, can manipulate our feelings and decisions, and can ultimately make decisions for us. Soon, at least some corporations and governments will be able to systematically hack all the people. We humans should get used to the idea that we are no longer mysterious souls. We are now hackable animals.
Are we hackable animals? How blurred are the lines between humans and machinery? Is there a point in which the artificial can become as real as the organic? How about improving upon it? It's one thing to talk about if AI will surpass humans in intelligence, or if the future robots will be run on organic brainpower. But what about integrating humans with technology? Look no further than Neuralink. Miraculously, 29-year-old Noland Arbaugh would be the first human to test out Neuralink's capabilities. Noland is a quadriplegic, but he would get the opportunity to experience what it would be like to essentially have telepathy, the ability to control external devices using their mind while connected to their computer or smartphone.
I think it just became intuitive for me to start imagining the cursor moving. Basically, it was like using the force on a cursor, and I could get it to move wherever I wanted, just stare somewhere in the screen, and it would move where I wanted it to.
Not only has humans interfacing with technology granted cyber telepathy, but it has also given some amount of vision to the blind. In 2013, Second Sight created the Argus II, which offered prosthetic vision in the form of transmitting a primitive pixelated version of the world to the user's brain. A small chip that conducts electricity would be implanted in the retina, in which it would then connect to the optic hardware processing the visual data into 60 black and white pixels. However, due to costs, founder and CEO Robert Greenberg struggled to find a way to make this technology financially viable. Each device was sold at $150,000. If you factor in the cost of surgery and rehab services as well, the costs ended up being nearly $500,000. In 2020, the CEO left the company and 75% of its employees were laid off. The company was imploding, auctioning off equipment to prevent bankruptcy. Existing patients learned the hard way that their implant technology was no longer supported due to the state of the company. One patient would attempt to reach out to Second Sight when his equipment fell apart, but with no response. Luckily, they were able to contact another Second Sight patient who was no longer using their system and found a doctor who could help. With technology in general always rapidly adapting and changing, this serves as a warning to early adopters of breakthrough cybernetic advances to make certain that their equipment can be upgraded or serviced in the future. Additional concerns with cybernetics brings us back to the question, are we hackable animals? Through a combination of medications, electrical currents, and cybernetics, researchers have tested if they could manipulate the movements of many creatures, such as rodents, cockroaches, and beetles. They have become successful controlling these creatures to bend to their will.
Here, the mouse on the right was made to walk in circles after a drug was injected into specific brain cells. The scientists say they were able to determine the path a mouse walked when they stimulated the brain in different ways.
The head transplant procedure involves removing a person's entire head containing the brain from their current diseased body and attaching it to the body of a healthy, young, brain-dead donor. Head transplants could provide individuals with severe medical conditions such as terminal cancer, paralysis, spinal cord injuries, or neurodegenerative diseases the opportunity to have a fully functional body while preserving their consciousness, memories, and cognitive abilities. The neurons are the longest-lasting functional cells in the human body, and according to our estimates, the brain is capable of lasting several hundred years provided that the rest of the body remains young.
In 2015, Dr. Sergio Canavero aspires to be the first to conduct a successful human head transplant. Valery Spiridonov, 33 years old, signed up as a volunteer. Since he had a muscle-wasting degenerative disease that paralyzed him over time, he seemed like a great candidate for the trial. But has a successful transplant ever occurred in animal experiments? Sort of. 1908, Charles Guthrie conducted experiments with dogs. He would sew one head onto another. As long as it had a source of blood, the dual-headed dog could survive up to a few weeks. 20 different two-headed dogs would be experimented on before he would conclude his research. Since then, monkeys and rats would also be targets of these experiments over the last century. Again, some success in functionality. But they would all pass after a short time. While Valery was waiting, his disease stopped progressing. It had gotten as worse as it would ever get. His body had stabilized, and over time, he would get used to the limitations of his condition. Soon after, he would meet Anastasia Panfilova, a woman with a master's in chemical engineering, and the two would later get married. He was then faced with the option of either being stuck with his body, but guaranteed a life with his now wife, or risk a highly experimental surgery with a likelihood of him not surviving the operation. Valery would choose the girl. He now lives in Florida, has a child, and runs his own software company. If one day head transplants have a 100% success rate, where might we obtain such donors? From a brain-dead coma patient? Could we one day grow and harvest our body replacements in a lab? Or maybe we'll exchange our bodies for completely cybernetic ones. One could use their imagination of the possibilities, both wonderful or horrific if ethics goes out the window. Where do you think humanity will end up in the decades to come?